Domain of radical functions. Recall that the domain of a function is all of the x values that the function can have or is allowed to have. And the range of the function is all of the y values. So the domain of a function f of x equals 1 over x plus 4. So this is a rational function, which we saw earlier. The domain was all values of x except when the denominator is 0. So we had to say x plus 4 is not allowed to be equal to 0, or x is not allowed to be equal to negative 4. So the reason why values aren't allowed in the domain is because they break the function. They break the rules of the math, which is that you're not allowed to divide by 0 in this case. But we're talking about radical functions in this lesson. So now let's think about the domain of a function like f of x equals the square root of x. What is x not allowed to be? What are you not allowed to take the square root of? And the answer is x can't be negative. And the way we write that is with an inequality symbol. So we'll say that x must be greater than or equal to 0. And this is the domain of f of x. So the radical, what's underneath the radical, has to be 0 or positive. But what about the function f of x equals the square root of 3x minus 4? Well, the same principle applies. What's underneath the radical has to be greater than or equal to 0. So that means that 3x minus 4, that whole unit, 3x minus 4, must be greater than or equal to 0. Now, we always write the domain as related to x. So we don't want to write it with this complicated expression around x. So we're going to rearrange this inequality equation. So 3x, we add 4 to each side, plus 4, and we have 3x is greater than or equal to 4. Then we divide each side by 3, divide by 3, divide by 3, and we have x is greater than or equal to 4/3. This is the domain. So I'll write domain. X is greater than or equal to 4/3. If x is less than 4/3, then it will make the value of this expression here negative, and you'll have the square root of a negative number, which will mean that the function will not exist at that x value. If we want to find the domain of f of x equals the square root of negative x, well, we're going to do the same thing. This whole expression that's under the radical, negative x, it has to be greater than or equal to 0. Again, we need it to say x is something, not negative x is something. So we have to get rid of that negative 1, or that negative in front of the x. And the way we do that is we'll divide each side by negative 1. And you'll have to recall, though, that when you divide by a negative number around an inequality sign, it's going to flip the direction of the inequality. So divide by negative 1, we're left with regular positive x is less than or equal to now, and 0 divided by negative 1 is still 0. So really what that did is it flipped the negative sign, or it flipped the inequality, but it got rid of the negative sign. And here's our domain. x is less than or equal to 0. And we could test a point that's less than or equal to 0. Like let's try x equals -4. If we were to plug that into f of -4, plug that into the function, we'd have the square root of negative, then the value of x, which is -4, and those two negatives would cancel and leave you with the square root of +4, which does indeed exist. So you can see that it's all the now negative values of x that are in the domain of this function because of this negative in front of the x that's in the function itself. And one last interesting example, find the domain of f of x is equal to square root of 6 over x minus 1. So this is an interesting one. It has a couple of different components to it. So we have to, whenever we're talking about domain, we have to think about what x is not allowed to be. So first of all, let's notice that we have a fraction and recognize that the fraction is never allowed to be equal to 0. So that means that just like with those rational functions, x minus 1 is not allowed to be equal to 0, which means that x is not allowed to be equal to 1. So we have to note that when we're writing our domain, that x is not allowed to be equal to 1. And then the other part of this is that we have the square root of this rational expression, and that the square root of anything has to be greater than or equal to 0. So 6 over x minus 1 has to be greater than or equal to 0. Again, this whole unit here has to be greater than or equal to 0. So, it looks tricky and it's not super easy to see what x needs to be right away. But what we need to recognize is that you have +6 on the top of this expression, and below you have x minus 1. Well, in order for that to be greater than or equal to 0, you have a positive number divided by x minus 1. That means that x minus 1, in order for this to result in a positive value, also has to be positive. If x minus 1 was a negative value, then 6 divided by something negative would be negative. So in order for it to be positive, x minus 1 has to be greater than or equal to 0. So x has to be greater than or equal to 1. And this is where we have to link our to what we know about the domain. So from the fact that we have a rational expression, x is not allowed to be equal to 1. And from the fact that we have this radical symbol, x has to be greater than or equal to 1 in order for us to have a positive value underneath the radical. Well, by linking those two things, we can see that our final domain is that x has to be greater than 1. Because it has to be greater than or equal to 1 to satisfy that radical requirement, but it also cannot be equal to 1. So we have to get rid of our equals part of our equals part of the inequality. So the domain that satisfies both of those requirements is x is greater than 1.